Last time we was talking about sound waves, and we said that it's longitudinal and mechanical waves. Longitudinal, that means the vibrations are parallel to the direction of the wave propagation, and mechanical, that means it's any wave that's mechanical needs a medium to travel through. Okay, and whenever the medium is denser, okay, the molecules make the wave travel faster. And one of the examples about sound wave, okay, that's we have different media. Okay, vacuum, air, water, steel, okay, and the speed approximately through each one of them. You have to know these values, these numbers, okay? And we know that the range of hearing of a human, okay, normal human range, okay, it's between 20 to 20,000 hertz. Above 20,000 hertz, it's called ultrasound. Below 20 hertz, it's called infrasound. And whenever you get older, the range of hearing will be shorter and smaller. And we said that okay, last time that when the sound travel, it causes a series of compressions and rarefactions, okay, and we demonstrated by the flinking of the water wave, and we tried to make it in graphs, distance time graph or displacement time graph or the time displacement graph or whatever, or atmospheric pressure, to know the differences between compression and rarefraction in whatever the graph it is, and how we can figure it out, the wavelength, the period, and finally the speed of the sound wave. Okay, then we say that we have something called pitch and loudness. The pitch is the frequency and the loudness is the amplitude. Okay, and we can change the frequency by changing the pitch of the sound. That means if it's sharp or deep, high tune or low tune. Okay, the same thing for loudness, if it's quiet or loud, okay, by changing the amplitude. Okay, then we talk about the echo and how we can use echo technique to find out the speed of sound, okay, by doing an experiment in front of a wall with a large distance, and this distance is supposed to be greater than what? Greater than how much? Greater than approximately 100 meter. Okay, if it's 200 meters, it would be better. Okay, let me fix this. Okay. And whenever it's bigger or distance, it will be more accurate. We clap the hand several times, and each time we can hear the sound, okay, of the echo, we clap our hands, so we have a constant rhythm, and then we measure the time intervals for 10 time intervals, okay, then we divide this time by 10, okay, then we can use it to find the formula speed equal what? Twice distance divided by time. And the distance here we can measure, use a measuring tape to measure the distance. Okay, we multiply it by 2, then divide by what? Divide by the time. Okay, but and also we can use it in something called echolocation. If we know the speed of sound, we can know how far are things from, and that's what they use in boats, submarines, okay, to know how far things from each other or inside the ocean. And that's echolocation. They use it in radar, they use radio waves, okay, or this, and we take it from dolphins and bats, okay. There was a homework. خلينا نشتغل مع بعض and نشوف who can tell me the answer for the first question. Yes, first question. Okay, a fire alarm is not loud enough. Okay, engineer adjust it so that it produces a note. Okay, same pitch with loud, which is louder. Okay, which effect does that have to the amplitude and to the what? To the frequency. So same pitch, but is what? Louder. Okay, so I have here from several of you, Marwan, Adham, Muhammad, Salma. Yes, thank you. Okay, they give me correct answers that the amplitude is larger, but the frequency is the same, and the answer is B. شكرا لكم. في ناس لسه ما بعت لي الأجوبة، ما أعرفش ليش. المفروض you have to send me the homework, okay, and you didn't send me the homework, or also some of you didn't send me the answer now. Okay, question number 2, no problem. خلينا نجرب مع بعض. Okay, question number 2. شكرا الشباب اللي عم بيبعتوا الأجوبة على السريع. 2 astronauts with radios, okay, can only communication in the space if their helmets, okay, are touching. There is no air in the space. What does this show about the sound? Travel through vacuum, travel through what? Solid. Can it travel through vacuum? Can yes, it cannot travel. So this one and this one is neglected. Okay, can travel through soil, yes, yes. So the correct answer, yes, shukran Adham, Muhammad Abdul Rahman, and Marwan, and Ilaf, and all the people that send me the answer. The answer is B. Thank you. Question number 3. Let's do it. What this is? A girl produces a certain note, okay? She blows gently into an organ pipe. If she blows into the pipe harder, the most probably change of that for the sound that it will have. Louder, okay, lower amplitude, greater amplitude, higher frequency, lower frequency, and the correct answer is C. Yes, it will be greater what? Amplitude, because I'm not changing the frequency here, I'm only changing the amplitude. It makes it louder. Question number 3. Question number 4. The diagram here shows what? The diagram shows a man stand at X here, okay, who shout on a man standing at Y, as you can see here, below it or to the south of it, okay. The man's voice will be heard sooner, okay, and more clearly if the wind blows towards which direction? شكرا للشباب اللي عم بيبعتوا لي الانسرز. Yes, yes. Another answer. أيوة. Thank you. Bravo. Okay, towards the south. Excellent. Because whenever the direction of the wind is the same direction of the waves of the sound, it will be louder and clearer. Okay. Question number 5. What do they ask? 5. What is the approximate value of the highest frequency that can be heard by a young person? Exactly, it's 20,000 watt hertz. Excellent, excellent. شكرا لكم جميعا. Okay, question number 6. It needs calculation here. What they ask? Look here. To estimate the width of the valley, a climber starts a stopwatch as he shouts. Okay. He hears an echo from the opposite side of the valley after how long? 1 second. That means the sound goes and rebounds, okay, covering this distance how many times? Twice. The sound has traveled with a speed of 340 meters per second. What is the width of the valley? Now we can use the echolocation formula. Distance equal speed times time, but we will divide it by what? Divide by 2, exactly. And it will be 340 multiplied by 1 divided by 2, and the answer will be 170 watt meters. So the answer is B. The answer is B. Why the answer is B? There is echo here, so we have to divide by 2. If you didn't divide by 2, you will get a mistake. Again, the sound here traveled this distance of the valley, the width of the valley twice, going and rebounds back. That's an echo. That means this time it's 1 second to go and return back. So it's half second to go once. Okay, I need to know the width of the valley. How far is the other side of the cliff of the valley here? Okay, so distance equals speed times time divided by 2. Okay, why divide by 2? Because there is an echo. They give us how much the time to go and return back. You can say you can divide the time by 2 by itself, or the whole thing be divided by 2. It will be the same result. So the answer is what? B. Be careful. Okay, some of you send me wrong answer. Okay, question number 4. 4 sounds W, X, Y, and Z are displayed, okay, by an oscilloscope screen. The oscilloscope settings are the same in each case. Which of the 2 sounds have the same pitch? Same pitch, that means I'm talking about the same what? The same frequency here. Same pitch here, that means I'm having same what? Frequency. Same frequency, that means I will have the same number of vibrations every second. Okay? So which one is the answer? Look here, I have 1.5 wave, 1.5 wave here. I have 1, 2, 3 waves here. I have 3/4 here, 3/4, and here also I have 1.5 waves. So which one have the same number of vibrations divided by the same time, same frequency? It's W and Z. So the answer is what? B. Okay, then say same amplitude, because same amplitude it will be X and Z, or W with Y. Okay, but didn't say the same loudness. Okay, how much the amplitude go up or to go down. Okay, they ask about the frequency, the pitch here. So that means this during the same time. This is oscilloscope. It has a certain time for each division here in the x-axis. Okay, as you heard before, and I'm going to explain it later. Okay. Next question. Question number 7. We finished it. Question number 8. What they ask? A sport field next to a large school building. At a far side of the sport field, a student sees what a groundsman hammer a pole into the ground. The student hears 2 bangs. He hears 2 bangs each time of the hammer as if he hit the pole. Okay, why does the student hears 2 bangs? Okay, now one of the unrealistic answers that the sound hears from one from the right ear and one of the left ear, and that's impossible. Yes, so the correct answer that the sound reaches the student directly from here to here. That's the first sound, and the second sound is as it reflects from the building and go back to him. The sound reaching the student directly, and the second sound due to an echo from the building. So the answer is C. شكرا يا شباب وصبايا اللي عم بيجاوبونا. Thank you. That's number 8. Number 9. What do they say? Sound are made by vibrations of vibrating objects. A certain object vibrates, but okay, a person nearby cannot hear any sound. There is no sound can be heard. Okay, which statement might explain why nothing is here? The amplitude is too large. If it's too large, I will hear it. It may be annoying for me. Okay, if the frequency is too high, above the normal range of hearing, it's accepted. The sound are transverse. That's not accepted answer at all. It's not a reason already. Okay, the speed of sound is too high. That's cannot be happen. So the answer is what is B. It's not a reason to make I can't hear because the speed of sound is too fast. No, it's not the correct accepted answer. Okay. Now in number 10, what this is. In a test, a car horn is found to be too loud and the pitch of the note is too high. Okay, so it's too loud and too high what pitch. Okay, what information does this have about the amplitude and the frequency of the sound? That's question number 10. Yes, the answer is أيوة. شكرا يا سلمى, شكرا يا مروان. مين كمان? Who can give me the correct answer? شكرا يا محمد. Yes, شكرا يا إلاف. It's A. Thank you. It's too large because it's loud and too high. So loud, that means the amplitude is high, and too high note, that means the frequency also is too large. Okay, so the answer is A. شكرا يا حازم. طيب, next question number what? Question number 11. A ship sends a pulse, okay, to a sound vertical downwards to the seabed, okay? An echo hears after how long? 0.4 seconds later, okay? If the speed of sound in water, they give it, it's 1,200 meters per second. How deep? They ask about the distance here. So we know that speed times time, but because there is an echo, I have to divide by what? I have to divide by 2. So 1,200 multiplied by 0.4 divided by 2, and by using calculator, how much is the answer? Divide by 2, it will be how much? Here, 0.2, it will be 480 what? Or 200, I'm sorry, 240 meters per second. 240 meters per second, so the answer is A, okay? Good. Next, question 12. Sound travels at different speeds in air, okay, water, and steel, okay? For these materials, which row is correct? The sound travels slowest where? Of course, in air. The sound travels fastest is, of course, in what? Through steel. So the answer is what? Is A. Sound, whenever because it's mechanical wave, whenever the medium is denser, it's heavier, the molecules are closer to each other, the sound will be travel faster. So through air, the molecules are far because it's a gas compared to liquid or solid. So that's why through sound travel through air slower than through water and fastest through air, through the steel. So the answer is A, question number 12. Number 13. A police car siren, okay, emits two different sounds, P and Q. Okay, this is P, this is Q, this is P, Q, tira, as you know. Okay, these are produced alternately. Okay, the diagram represents the two sounds emitted. Which, okay, sound is louder, and which has a lower what pitch? Now, louder, you know that it's a greater amplitude, which is B. Okay, so louder is B. Which one has a lower? That means during the time, the number of vibrations, it will be less. So also there is less number of vibrations during the same time interval. If at the same time interval here, you can see 1, 2, 3, 4 waves, but here it's 2. So also what? P, okay? So the answer is A. شكرا للجميع اللي عم بيجاوبونا يسلموا ايديكم. Okay, like this we finish the multiple choice questions. Anyone get 10 or above out of 13? Tell me. 10 or above, if you please tell me. Okay, شكرا يا ليث. Okay, so can you go through 12 again? Now they ask, we have 4 different media. Okay, it's 3 different media, air, steel, water. And we know that which one is the slowest. We said that here before. Okay, here. That speed of sound through air, approximately 330. You have to know this number. Through water, approximately 1,000. Through steel, it's approximately 5,000. So where is the slowest? It's in air. Where is the fastest? It's through steel. Why? Because the medium, okay, it's denser. And the sound is mechanical wave. That means whenever the medium is denser, the speed will be faster. What did you say, mister? I couldn't hear you. Is my voice clear now? Is my voice clear? Can you hear me? Okay, alhamdulillah. Maybe there is a problem with the internet connection. Okay, let's move on to question number 2, page 31. If you have any question, you can send me on the chat. Later on the night, I'm going to explain to you or answer, or in the end of this session, okay? Question 2. A sound wave in air is made by compressions and what? Rarefactions. State what is meant by compression. Now, of course, it causes region of high atmospheric pressure, but is not the definition to say this. What is meant by compression? The region or the area, the region where what the molecules, because I'm talking about the air molecules, no problem, the particles or the molecules, where the air molecules are close to each other in sound waves, causing high atmospheric pressure. Causing high atmospheric what? Pressure. You can say the opposite here in what? In rarefaction is the region where the air molecules are not close, they are far from each other, okay, in sound wave, causing low atmospheric pressure, okay? Is it clear? Good. Now, what this said here, the distance between two consecutive refractions, it's 2.5 meter. What they give us here in this question? What does 2.5 represent? Yes, tell me. When they say the distance between two consecutive rarefactions is this, what this distance represent? What do you mean, Muhammad? Who can tell me this 2.5 represent what? Okay, let's continue. The speed of sound is what? 330 meters per second. Okay, that's the speed. Calculate the frequency of the sound. Yes, shukran, Marwan. Marwan, tell us what this 2.5 represent, and it's not an echo. What does the
lambda?
What do we mean by lambda?
Wavelength.
Wavelength. So speed equal frequency multiplied by wavelength, and they ask about the frequency. So frequency equals speed over wavelength, and the speed, which is 330 divided by 2.5, and by using calculator, how much is the answer? 132. Let me check. 330 divided by 2.5. Yes, the answer is 132 what hertz. That's the frequency here. Okay, تمام. تمام. Okay. Next, what they say here. A person makes a loud sound and hears an echo of this sound 1.2 seconds later. This is the time to go and return back, which is what? There is an echo here, okay? So it's a reflection. Calculate how far, they ask about the distance here, how far a person is from where? From an object causing an echo. You can assume that the speed of sound is still 330 meters per second. So we know that distance equals speed multiplied by time divided by 2. Why I divide by 2? Because there is an echo here. So 330 multiplied by 1.2 divided by 2, and the answer, yes, shukran, 198 what meters, approximately 200 meters. Yes, good. Okay, if you want to write this down, I'll take a screenshot. Now let's move on to question number 3 in this page 32. In question number 3, what do they ask? خلينا نحل مع بعض. The figure below shows how air water pressure at one instant varies with the distance along what the path of a continuous sound wave. Here there is no zero, there is normal atmospheric pressure, and goes higher or lower than what? Than the atmospheric pressure. Part A, what type of waves are sound waves? Send me the answer. What type of waves are sound waves? Thank you, Marwan. What else? You have to tell me 2 things, not only 1 thing. Who can give me the correct answer? What type of waves are sound waves? No, they are not transverse. They are not going up and down. Okay, I can see that the air pressure keep going up and down, but it's not exactly, it's longitudinal. So longitudinal and mechanical. Longitudinal and what? And mechanical what? Longitudinal and mechanical waves. Okay, tamam. So again here, okay, in this question number 2, okay, if you have any question, you can send me. Question number 3 now. We did the first part, you are welcome. What type of waves it is? It's longitudinal and mechanical. On the figure, okay, on this figure, mark on the axis PY, okay, 1 point C, where a compression in the wave. Where there is a compression? Who can tell where the compression is? Is this point compression? Is this point where I label is the compression? No, it's a crest and it's called a high pressure, and that's not correct. They tell us draw on the same axes. So which one is the correct answer? Yes, exactly. It's here when there is high atmospheric pressure. This is what a compression, I will use letter C to represent it. And when there is low atmospheric pressure, I will use letter R to represent how the rarefaction, okay, is produced. Part C in this question, what they say? Describe the motion of a group of air particles instead of the path of the wave, okay, shown in the figure above. Now they ask about the description of the motion of the group of air molecules. How do they move? How do they move? You have to say that they keep vibrating because they are longitudinal. They keep vibrating parallel to the direction of the wave propagation, or you can say forward and backward, okay? And this movement causes the group to cause a series of compressions and rarefactions. That's what you have to say. So if I want to write it down, what I'm going to say here? They keep vibrating or oscillating forwards and backwards, parallel to the direction of the wave propagation, causing series of compressions and rarefactions. So every time they ask this question, they keep changing the mark scheme, but it's still having the same keywords, that oscillating parallel, okay, and causing series of compressions and rarefactions. Good. Now, last part here of this question, D. The sound wave, okay, shown has a speed of 340 meters per second. Ustad, why they keep changing the speed, 330, 340? It depends on other factors, okay? Okay, I'll talk about air, but maybe there's different humidity, different temperature. That's why the speed changes a little bit, okay? Like in the water, maybe the salt water, different speed than fresh water, and the temperature changes, causing different speeds. That's why. So the sound wave shows, shown has a speed of 340 and a frequency, okay, of how much? 200 hertz. Calculate the distance represented by px on the same figure here. Who can tell me px from here to here? What they ask about? They ask about what? Yes, what do they ask about?
Wavelength.
Do they ask about the wavelength? I know that the wavelength for the whole wave for positive and negative pulse, this is a wavelength. So what they ask for? They ask about
Half
what?
of a wavelength.
Half of the wavelength. So I have to find the wavelength, then I will divide it by how much? Exactly, I will divide it by 2. So exactly. So we know that speed equals frequency multiplied by wavelength. That means wavelength equals speed over frequency, which is 340 divided by 200. And the answer, it will be 1.7 watt meter. But the distance px is, as you told me, it's half wavelength, lambda divided by 2. So 1.7 over 2, which is equal to 0.85 watt meter. And the unit is meter because they give us the speed here in meters and the frequency in hertz, so it stays in meters. So that's how we answer this question number 4.